Okay, testing your alternator. First of all, identify your battery. That terminal there is the negative, this terminal here is the positive, and it's 12 volts DC. Okay, a lot of the times you get a negative next to the negative terminal and a positive next to the positive terminal. Okay, that's just a bit of a quick update. Now then, what you need is a multimeter, and we'll just zoom down on these one at a time to show you the various features that you need. Okay, it's not technical. The V with a straight line and 3 dots underneath it means DC. Okay, the V with a wiggly line means AC. You want the DC, and on this one I'm setting it at a scale of 20. If you get it wrong, like you got it on the 2, doesn't matter, nothing nasty is going to happen, it's just it won't read. If you get it on the 200, it will read, but the decimal point will have been moved over 1, and that's a bit irrelevant really. Okay, now then, on the more generic type meter, you have to turn this to switch it on. Okay, so we've got volts AC there, and we've got volts DC here underneath all the muck, and for this one I would just put it on the 20. Okay, that's not difficult. Right, the main thing is you start the car up and you put the lights on, the fan on, the AC on, all sorts of things. So this is going to be a bit noisy, and what I'll do is I will talk about it afterwards, but basically you need to start the engine and load the car up electrically, everything switched on, and see what the volts are on the battery, because you can get a point where you think the alternator's alright in summer, but in winter it doesn't seem to charge enough, and I'll explain the reason for that later on, and that's the bit that you can skip if you're not interested. So I'm going to start the car up and switch everything on, and then we'll put the multimeter across the battery. .3, that's grand. So as you can see, that was 14.3 volts DC. That was with all the lights on, main beam and everything, and the blower fan on full bore. So it's pulling power out of the battery system, and it was holding up. So there you go, and I'll explain the reason in a moment. So here's the reasoning on that partial output. Is you have 3 wires, power wires, coming out of your alternator, and from each power wire, which is AC, you have two diodes. So these are rectifier diodes, and what they do is they split up the AC, which is a sine wave like that, and it sends the bottom half this way, which is the negative, and the top half this way, which is the positive. So you've got negative, positive, negative, positive, negative, positive. Yeah, okay, and so all the positives are linked together, and that goes off to the positive of the battery, and all the negatives are linked together, and that goes off to the negative. Okay, so you have power between there and there, there and there, and there and there. So let's say, for instance, this diode burns out. Okay, so now all you've got is power between there and there. It can't go between there and there, and it can't go between there and there. So you have 1/3 of the output of your alternator. So your battery light goes out, but you don't have enough power to run your lights and the blower motor and all the other ancillaries that a modern car uses. So in the summer, when you're running light, it seems fine, but as soon as you get the shorter days and it's colder, then it starts acting up and you start getting symptoms of a low battery. And of course, if you constantly run a battery at a low state and then occasionally flatten it, it's the quickest way to kill it, stone dead. So start your car up, put a load on it, and if the battery volts are something like, let's say 12, 12.2, 12.4, that sort of region, even 12.8, you know with a full load and the car running that you've got an alternator problem. Okay, hopefully this is useful. Check out my PayPal if you want to. Speak to you soon.